Hello, assalamu alaikum. Um, this is second part of JNCIA-Junos study guide, and chapter name is routing fundamentals. Here we discuss the basic routing operations and concept, routing and forwarding tables. That means RIB and FIB, configuration and monitoring, static routing, and basic voice web configuration. So primarily, I will give some basic concept of routing. I'll show you a picture here. There is this symbol contain the router, and this symbol is switch. This is very simple topology. Just I ask some question based on routing. Just if you want to send packet from user A to user B, there is need any routing to communicate from user A to user B. Any routing need? Jesus, this is a router, and this is switch. User A and user B can be connected in same subnet or can be connected in different subnet. Is there need any routing for communication user A to user B? Do you understand my question? Yes? No. Because this is a directly connected LAN. This is a directly connected LAN. User A can be connected a subnet or same subnet. Both are connected in a single router. So there is no need any routing protocol to communicate from user A to user B. They do not need any routing protocol. Yes, no need. Okay. Number question 2. User A want to communicate server B. User A want to communicate server B. Is there need any routing to communicate user A to server B? Yes, default route or need routing protocol. This router, internet cloud is one or multiple router, then another router connected server B. So when different subnet connected from different router, if we want to communicate router connected LAN, one LAN to another LAN, so we need routing protocol. It's maybe static routing or dynamic routing, but need routing protocol. Otherwise, they cannot communicate with each other. So this is the basic concept. Okay, then go routing components. So I already asked you the question. If user A needs to communicate with a device within the data center, what routing information do the layer 3 devices within the communications path require? One subnet is connected in a LAN, another subnet is connected with same router in another LAN. If user A or user B want to communicate with data center, is there need any routing protocol for communication from user A or user B to data center? This data center means there is a switch and connected multiple PC, multiple server like this. Need any routing protocol to communicate? There is directly connected routes. Yes, no need routing protocol. No need routing protocol. Yes, no need. Okay, this is the concept. Routing information sources. There is a different routing information sources. When you configure your router, you can configure static routing. You can configure dynamic routing. So all routing information sources will build a routing table. From that routing table, from that routing table, routers select the forwarding table. So what is the difference between routing table and forwarding table? One difference is that like if you consider here another router, this router is connected with this other. So there is a LAN, this is LAN 1, this is another LAN. If this user communicate with this user, so there is available this is a one path, this is another path. So this is there is two available paths. If we consider any dynamic routing protocol, one path will be the best for this source to destination for communication. So only best path will be forward to forwarding table, but all available path will be available in routing table. This is the difference between routing table and forwarding table. Only active route will transfer to forwarding table. But in routing table, all available path is there. This is the difference. Multiple routing tables in Juniper, you will get multiple routing tables, like name inet.0. This table is used for IPv4 routes. inet6.0 used for IPv6 unicast routes. If you configure MPLS.0 used for MPLS label switching, and inet.3 is used for MPLS path information or MPLS routing table. If you configure multicast, inet1 and inet2 table will be there, and also inet4. So there is different routing table here. In this course, we will familiar with two tables, inet.0 and inet6.0. inet.0 is for IPv4 unicast. inet6.0 is for IPv6 unicast route. Okay. Preferred routing information sources. In Cisco, this is basically called the administrative distance. But in Juniper, this routing preference or routing administrative distance is called the preference. This is the default preference. You can change it, and always less preference will be more preferred in a routing table. If you configure static routing, if you configure static routing in router, their preference will be default 5. But in Cisco, the administrative distance for static routing is 1. OSPF internal, OSPF internal preference is 10, and OSPF external preference is 150. For external route, Juniper use 150. For internal route, OSPF use 10. But in Cisco, both use 110. Okay, so there is some difference in preference or administrative distance between Juniper and Cisco. Like BGP, both eBGP and iBGP both use preference value or administrative distance is 170, but in Cisco, for eBGP use the preference value is 20 and iBGP for 200. So basically just memorize this table. Just understanding actually. And others route preference, which is less used. Show route, then route table. Route preference is static route. This destination is in the routing table. If I want to establish an adjacency between Juniper and Cisco router, it will affect routing preference value. Yes. In a Juniper preference, show if you configure OSPF, when receive any route from Cisco, if this is in OSPF internal or OSPF route, the Juniper will show the preference value is 10, and Cisco will show the preference value is 110. So there is no any trouble for communication if you configure Juniper and Cisco both parallelly, and in a network there is multi-vendor device will be present. You in your network there is maybe Cisco, Juniper, or MikroTik or others vendor device. This preference value will not give any effect actually. Okay, but Juniper device default use this preference value, which is different from Cisco actually. But there is no any challenge in production network. There is no challenge. Okay, so this router getting this route from a different two routing protocol. One is static routing, another is OSPF. So for static, the preference is 5. This comes from this table, and the static route preference is 5. Static. And OSPF internal preference is 10. This route comes in routing table from different routing information sources. One is static, another is OSPF. So which will be preferred? Which will be preferred? which preference value is lower, that route will be preferred. So for static, preference value is 5 and OSPF preference value is 10. That means 5 is less than 10. So static route will be preferred in that routing table, and that indicate the star mark. Star mark means this route is active and best. This route is active and best route. And this is the alternative route. If this path is not available, or this routing is not available, then this will be the primary path. And some other example, viewing routing table, show route. This is the command. In Cisco, we place here show IP route. Being the route table for especially in for IPv4 inet.0. This is the route table name, and star mark asterisk indicate that the route is selected as active route, and this is the routing source static OSPF, and slash the number is the preference value. If you want specific protocol route information, then place here show route protocol BGP, show route protocol OSPF. Okay. To getting the specific routing informations route table. This is the show route forwarding table. To getting the forwarding table information. Show route forwarding table. Forwarding plan. Just okay. There is a simple question. Test your knowledge. Use the following forwarding table to determine the next hop interface for packet destined to 172.19.52.101. If this router, one packet is coming in this router, and packet destination is this IP. This is the destination IP 172.19.52.101. It could be possible that the router is in routing table, but in the forwarding table, it could be possible that router is in the routing table, but not in forwarding table. Yes, the route, not the router. One route, this actually if we show here, consider another router is connected with this other. Consider here one route like 192.168.220.0/24. Okay. You configure here static routing or any dynamic routing. This route, if I consider from this router, this route can be in routing table through static routing or through dynamic routing. This route will be available there, but there is a different path. If this is the primary path, that will be the secondary path. Route will be available in routing table and forwarding table. But in forwarding table, this route next up will be the best or primary path. But in routing table, both path is available. Route and both path is available. But in forwarding table, only primary path is available there. Is it clear for you? Okay. Then I ask you this question. Just look this one. You are in this router. One packet is coming in incoming interface, and the packet destination IP is this one. 172.19.52.101. How to handle this packet? Just see this table and answer the question. Do you understand this one? Okay. Consider this is a router. There is maybe incoming interface, one incoming interface, and multiple outgoing interface. In incoming packet, getting one incoming packet. In incoming packet, the destination IP is 172.19.52.101. How to handle this packet? Router, how to handle this packet? They will forward which interface or which next hop, which interface router choose or which next hop choose to forward this packet. Primarily, when one packet is coming in router search this destination address is in the firstly the message which destination address will match this IP 172.19. Just look 172.19, that is okay. Then third octet is 52. The first line in the next hop is the MAC address. Yes, no, MAC address. Just I cleared this question. Just look this. So firstly, when packet is coming in router, they look up the routing table. When look up the routing table, they matching the destination IP with the destination prefix. So this destination IP 172.19.52, 172.19.52.101. So 16.52.16/28, this destination network not belongs 101, not belongs 101. So this minus 52.0/24, this belongs 52.101. This destination matching this destination IP 101 is in 52.0/24. Also, this one 52.0.0/16. This destination prefix has also this IP, and this is the default address, IPv4 default address. This is also, this IP is in this subnet, also this subnet. How to handle this packet? The higher prefix length, or we can use here sentence longest prefix match first. Longest prefix match first. So the longest prefix is the 24, then 16, and the 32. No, this is not the 32, it's actually 0. So here the longest one is the 24. So this destination will choose this next step and this interface to outgoing the packet or forwarding the packet. Okay. Do you understand the concept? Router, how to decide the destination prefix, or how to look up the routing table and select the forwarding path or next hop. Just as the router prefers the most specific route. Exactly. More specific route or longest prefix match fast. Similar sentence. Okay. So if the destination address is this one, who is next hop or who is outgoing interface will be selected for this destination. Z is 0 by 0 by 3, or Z is 0 by 0 by 1, or Z is 0 by 0 by 2. Which one will be selected? /16, yes, exactly. Because the IP is 21. Okay. /28, there is a range is 16 to 31. 21, this IP belongs to this subnet. Okay. And last one belongs to which subnet or which prefix? Last one. 17 to 25, 100 to 27. 19, no. There is starting is 25. 19 is not. So which one? This will not, this will not, this will not. Yes. Basically /0. Default route. This destination will choose the default route to forwarding the packet. Okay. Last one. If the IP is 172 dot 19 dot 255 dot 10. Destination IP is this one. Destination IP, this one. So which IP will be the next hop, or which interface will be the forwarding interface? 16. Okay, thanks. You understand this one. Okay. Overview of routing instances. In a router, there will be multiple routing instances. The default routing instances is master routing instances, and other routing instances you can create. Like one device is running the Juniper operating system. You create the instance customer A, you create the instance customer B, and also there is master routing instance. So in a router, there is multiple logical instance or logical routing table in a Juniper devices. So you just go to here. There is a two router. If you consider this router is a master routing table. One user, this is one user is connected with this router. Another user is connected with this router. This user also connected from this router. User 1 and this user is user 2 1. Here is user 1 2. There is another user group 2 2. You consider the two group. This group is this user and this user are in yellow group, and this user and this user is in blue group. If you consider user yellow group user cannot communicate with blue group, but yellow group user can communicate with each other. Also, blue group user can communicate with each other. If you consider this one, so this router have multiple routing instances. For yellow group, need one routing instances. For blue group, need another routing instances. But you have only single router. You have only single router. In Juniper device, it's simply it's possible one physical hardware to divide in multiple routing instances. Okay. In Cisco, this is called the VRF or VRF Lite, virtual routing and forwarding. This is the concept of divide one physical router into multiple routing instances. So this is the concept. And how to deploy this? Show routing instances, how to deploy this? I will show you in configuration. Routing instance, set routing instance type. There is multiple routing instance type, BRA, PPLS, virtual router. Okay. In MPLS, when you configure the MPLS for layer 3 VPN, we use BRA. For layer 2 circuit, we use BPLS, L2 VPN, or no VPN related applications, only just system virtualization, we use virtual router. There is a example of virtual router to how to create the virtual router and how to configure the routing protocol integrated in the virtual router. I will show you, and how to check this one routing instances, and how to check the communication between not a single routing instances, ping, trace, show, static towers. Okay, so I will show you first this lab, how to create the routing instances. Okay, this is your lab. Okay. We consider here two routing instances. One routing instance is yellow, another is blue. Okay. Mm, need Swiss or need PC to check. Virtual PC, VPC. Yes, VPC 4. Save. VPC. This to one. This to one. Oh. YOLO YPC1. YOLO PC1. The short name. And this name YOLO PC2. Blue PC1. This name is Blue PC2. Blue PC2. Okay. Then back interface PC1. Not connect first to interface. Later interface will be 1. Another interface is like 2. One. And the interface is 2. Okay. So topology is ready. For yellow, we consider here one subnet here. Duplicate. For yellow, here is consider 192.168.10.0/24. Get 11. Is it possible to emulate Huawei router? Yes, EVNG. Possible. Here is Huawei router. Huawei router. AR1000B. Also, you can deploy any 40 USC 600B. But AR1000B is very easy. Um, this is for low group. I use here the subnet is 20. Duplicate. Or we can use same subnet because they are using the different routing instance. They basically use a different, not need use the different subnet. I show here different subnet. 21. So for point to point, we use here duplicate. For YOLO, the point to point will be for YOLO, point to point will be 10 dot 10.10.0/30. Point to point will be this one. And for low, point to point will be 20.20.0/30. Okay. This is the consideration. We will create the two routing instances. One for YOLO. In YOLO group, this subnet and this subnet will be in YOLO group, and this subnet will be in blue group. One is YOLO group cannot communicate with blue group, but YOLO group PC1 can communicate YOLO group PC2. Blue group PC1 can communicate with blue group PC2. Using we will configure this one using two routing instances. One is yellow, another is blue. So first one, power on this device. And this will be in master routing table. Loopback interface and this point to point will be in master routing table. Next one. Store. Oh. This is your previous configuration. There is the back interface. There is also a physical interface. Z is 0 by 0 by 0. There is also Z is 0 by 0. So single interface. I will use here master routing instance, yellow routing instance, blue routing instance. All are communicate with single interface. So I configure here interVLAN, that means multiple unit to communicate with respective instance. Okay. First one, edit. Rename unit 0 to unit 1. Uh, set unit 1. VLAN ID 1. Only unit 0 is valid for this encapsulation. Family inet, unit 1, description, family. So rename unit 1 to unit 100. Set unit 100. VLAN ID 100. Set VLAN tagging. Show this one. Coming. Actually, I want to configure multiple unit in gig 0 by 0 by 0 for different routing instances. For that requirement, first you have to configure the VLAN tagging When one single interface you divide for inter-VLAN routing respect, then physical interface will be in VLAN tagging. Then you can choose multiple unit and respective VLAN, and you can configure multiple subnet to communicate with one router to another router or point to point. This is similar. If you consider with Cisco, this is similar router on a stack configuration. Primarily the VLAN encapsulation, then IP address. This is clear? This is in Cisco. We when we configure the inter-VLAN routing, there is one unit. You encapsulate one VLAN ID and you configure this VLAN network information. The unit and the VLAN must be the same. No. We configure here same for remembering the configuration, and it's very easy to understand, but not necessary. Unit number and VLAN number will be the same. It will be different. Like you can rename unit 100 to unit 1. Okay. Rename unit 1. Sorry, rename unit 100 to unit 1. So see here, the unit number is 1, but VLAN ID is 100. You check the configuration, no error. Okay. But when you configure in production, normally we use the unit number and VLAN number is same. But this is not the fixed rule, or unit number and VLAN number will be different. No issue. Basically, VLAN number logically communicate. Unit number is the locally significant number, actually. Okay, so set unit 1, VLAN ID 1. So unit 1, VLAN ID 1. We use in production in that pattern. Okay. So commit, and another router is BMX2. We consider this one also. First one is set VLAN tagging. First command, then rename unit 0 to unit 1. So this one. If I commit here, they will show the error message because we assign the unit number but not set the VLAN ID. Not set the VLAN ID. So the set unit 1 VLAN ID will be 1. So this is the perfect VLAN tagging, then unit number, then VLAN number, then address, then commit and check the communication. This is the 12.1. If I send ping from router 2 12.1, it's okay. They communicate with each other. There is 12.2 and I send ping 12.1. This ping will go through the master routing table. Go through the master routing table. That means run show route. This is the master routing table inet.0. for IPv4 routing table. For the inet.0 is used for IPv4 routing table. How would you see if you put show and display set? Show display set, that means show display set. The command you configure. Okay. Or you can mask G0/0, show mask G0/0, then display set. Or you can go first here, then place the show display set. This clear? I could configure in the same interface in another unit, different VLAN. Yes, obviously. So unit 1, I configure here only unit 1 for master routing table. I will also configure YOLO instance for one unit, and another unit will be used for blue instance. Okay. So in YOLO instance, our point-to-point IP is 10.10.10.10.0/30. So this unit set unit 10 VLAN ID. I use here 10 and address is family inet address 10.10.10.1/30 is the unit 10. You can copy unit 10 to unit 20. 20 is ready. Then set unit 20 VLAN ID will be 20. So okay, VLAN ID will be 20 and address will be rename unit 20 family inet address 10 to address 20.20.20.1/30. Multiple. Okay. VLAN 1, VLAN 10, VLAN 20, but in single interface. You can continue up to 4094. Last number of VLAN ID. Okay. Okay. So show then display set. This is the 10 unit and IP is I configure here this router. IP is here 2. Okay, done. Then for 20, IP will be last one is 220. Then commit. Then I also place here the commit. You can send packet for checking. Ping 10.2. Yes, getting ping. Or you can also send the packet of VLAN 20 to yes, getting ping. Okay. Then the interface configuration where your PC is connected G0/0/1 YOLO PC, G0/0/1 YOLO PC. Okay. In set interface ZE 0/0/1 family inet unit 0 family inet PC connected interface. Okay, PC connected interface G0/0/1 and address is 192.168.10.1/24. Commit. So plus that mass G0/0/0/1. Yes, this line and VMX2 interface is same G0/0/1 and IP will be 11.1 YOLO PC2. Then commit. Then blow PC G0/0/2. For G0/0/2, G0/0/2 unit 0 IP is 20.0. So here 20.1/24. If we copy this one, 20 BMX2. This interface is okay and IP is 21.0.24. Then commit. Also press the commit. And set IP in PC. BPC1 and YOLO PC1, YOLO PC2, Blue PC1, Blue PC2. Okay. Set PC name. PC name is YOLO PC1. Set PC name YOLO PC2. Set PC name Blue PC1. Set PC name Blue PC2. And then IP. How to set IP? IP, then address, mask, then gateway. IP, like coming here, YOLO PC1 10.IP 192.168.10.10/24 and mask is 192.168.10.1 is the gateway. 10.10 is IP and 10.1 is the gateway IP. Okay. YOLO PC1 IP setting done. And then go to YOLO PC2. IP will be 11.11 and gateway is 11.1. Okay, then Blue PC1, IP is 20.20, 20.1, 20.1, Blue PC1, Blue PC2, IP is 21, 21, 21.1. Okay. If I send ping to this IP, just send ping this IP. Is this packet go from PC1 to PC2, PC1 to YOLO PC1 to YOLO PC2? Is it possible to send packet from YOLO PC1 to YOLO PC2? Possible? Jesus? Uh, need routing or no need routing? Same routing instance. Yes, same routing instance, but routing protocol is needed or not needed to communicate to communication between ULPC1 and ULPC2. Routing protocol is needed. Different router. So routing protocol is needed. Yes, needed. Otherwise, they cannot communicate. Otherwise, they cannot communicate. Okay. So if I send destination host unreachable, if I send packet to gateway, that will work. Yes, that will work. But cannot send ping to PC1 to PC2. So need routing protocol. If I configure here routing protocol, like PC1 can communicate with PC2, yellow PC and blue PC. So you can configure the routing protocol, set routing options static. If you configure static routing in Juniper, this is the way. Set routing options static, then route, then destination. I'm in VMX1. I want to reach this network 11.0 and 21.0. So if I communicate 192.168.11.0/24, the next hop will be the 11.0 for 11.0/24. Next hop will be 10.10.10.2. 10.10.10.2 dot 2. Right? Okay. Edit routing options static. Show this one. Show display set. Now 12.12.12. This for master routing. This for master routing table. 10 is for yellow group. 10.10.10 is for the blue group. And 12.12 is for master table, master routing instances. That's why I chose this next hop. Okay. Then if I set here the VMX2, that next up will be 10.1 and destination for VMX2, ULPC1 10.0. This network will be the destination. Okay, like Cisco. If I send now ping, that will work. Okay, that means need routing. Similarly, when you send packet from blue PC1 to blue PC2, need also routing. Like in blue PC, that is IP is 21. From BMX1, your destination is 21.0/24, and next stop will be 20 20.20.20.20.2. This will be the next stop, and show mass static display set. If I configure this one, no, this will be the one, and this will be the destination will be the 20. I'm in VMX2. My destination is 20. So when I reach the 20 network, the next stop will be 1. So if I place here, so now we can send packet blue PC1 to blue PC2. But there is a problem. Problem is when I send YOLO PC1 ping YOLO PC1 to blue PC2, YOLO PC1 to blue PC2, they also can communicate. But our first requirement was YOLO PC cannot communicate with blue PC, but YOLO PC can communicate with YOLO PC that will be in same router or will be in different router. So here, static route you need add the routing instance. No need the routing instance. I will go now routing instance. Routing instance for separate routing table. Okay. I configure here all are in single routing table. Run show route. All are in single routing table. That is inet.0 or master routing table. Now I separate routing instance for yellow group and blue group. This is the sample configuration. This is the sample. How to do this? Now create the routing instance. First, I will show you the problem. Yellow group can communicate yellow PC and blue PC. Now we configure routing instance for yellow group and routing instance for blue group. Then we check yellow group cannot communicate the blue group. Only yellow group can communicate the yellow group. Okay. For that requirement, we need the routing instance. Just as clear? This is it okay? No, not only VLAN. No VLAN. Just create now. I show you. Edit routing instance. Routing instance name YOLO. You are now YOLO routing instance. Nothing is here. Set instance type. Instance type is virtual router. We are making the virtualization here. BMX1. BMX1 have two routing instances. One is yellow, another is blue. Others is master routing table. Set routing instance. This is the virtual router. In this virtual router, there is YOLO routing instance. So YOLO routing instance interface is the 0 by 0 by 1, and here is the another interface Z 0 by 0 by 0 unit 10. So this first one is the interface and last one is the routing. So just set interface Z 0 by 0 by 1, that is 10.0/24. Z is 0 by 0 by 1, 10.0, Z 0 by 0 by 1, 0 by 2, 0 by 0 by 1. Side interface 0 by 0 by 1. This interface will be in YOLO routing instance G 0 by 0 by 1 and 10.10.10. This network is Z 0 by 0 by 0.10. This interface also in YOLO routing instance. Okay, these two interface in YOLO routing instance, and what you can configure different routing protocol here. You can configure WSPF, you can configure static routing. Just for simplicity, we configure here static routing. Top edit routing options, show display set. Now no need this one. Now delete this route from master routing table. Delete this route, then go to YOLO routing instance and set the route in under YOLO routing instance. Damn it. Now it is clear. Oh, yes. Okay. So in YOLO routing instance, you just create one instance. In YOLO routing instance, this interface and 10.10.10, this two interface will be in YOLO routing instance, and your routing also under YOLO routing instance. You can configure static, you can configure WSPF, you can choose your routing, no issue. Okay. First instance, we use a static routing. In blue instance, we configure WSPF. Okay. So this routing instance, that's done. Now go to VMX1. VMX1 is first. I configure here 10.0, 10.0, 10.1. Okay, VMX2 done. Then go to VMX1, edit routing instance. Instance name is YOLO. Instance name is YOLO. Set instance type virtual router. Virtual router. Then which interface will be there? Set interface in YOLO routing instance. Our Z 0 by 0 by 1. This interface will be there. G 0 by 0 by 1 unit 0. This interface is double here. Interface, and another interface will be set interface unit 10. This interface unit 10 and unit 10. This interface. Okay, then back, edit routing options, show display set. So this is the master routing table. I'm in VMX1. I want to go VMX to 11.0. So this is in master routing table. We delete from master routing table and set this configuration. I will configure for YOLO static. Okay. Edit routing instance YOLO. Then place the static routing here. Done. Then top. Then commit. Run show route. There, just see there is two routing table. One is inet.0. One is inet.0. This is the master routing table. And another one is YOLO.inet.0. This is the YOLO routing instance table. Okay. Look, this route 192.168.10.11. This route not available in global route table or master routing table. Only available in YOLO routing instance. Okay. If I send now YOLO PC to Blue PC, they cannot communicate. They cannot communicate because YOLO PC in a YOLO routing instance, but Blue PC in global routing table. So this one routing instance to default routing instance or another routing instance, communication is not possible. But if I send YOLO PC, it's communicate. YOLO PC 1, I send packet to YOLO PC 2. They are communicating with each other. Okay. Second step, we configure the another routing instance, Blue. Routing instance show edit BLUE Blue. So there is nothing. So the set instance type is virtual router and set interface for Blue routing instance. Our interface is Z0/0/2, Z0/0/2. So the interface is Z0/0/2 and point-to-point interface, the VLAN ID or unit number is 20. Unit number is 20. So these are the Blue routing instance and we configure here OSPF routing in Blue routing instance between router 1 and router 2. How to configure this one? Just set protocol OSPF, define the area ID and add the interface. Simple. Then go to VMX1, set protocols. Is it similar to VRF Lite? Yes, exactly VRF Lite. Okay, exactly VRF Lite in Cisco. Set protocols OSPF. Set protocol OSPF and then set the area ID. I use here single area OSPF. Then set the interface. Our interface is to Z0/0 this one, this interface, and another interface is Z0/0/2, this one. Okay. Well, OSPF configuration done. Then top edit routing options. Here is no need this configuration. Basically, we remove this one. No need this one now. Delete. commit. So show mesh blue, then display set is the blue routing instance configuration in router 1. In router 2, BMX2, edit routing options, show, delete. Yes, you can delete everything under routing options. So just blue routing instance interface is same for both router. This router also use the 0x0x2 and unit 20. So just copy paste here, done. Then interface is also identical. VLAN 10, 20 and line interface is 0x0x2. So just then commit. Run show route. We see here 3 routing table. One is blue, one is yellow, and another one is master routing table. This is called the inet.0. inet.0. Okay. Um, if you check now, send packet YOLO PC1 to YOLO PC2. YOLO PC IP, YOLO PC2 IP is this one. Ping from YOLO PC1. Let's communicate. Again, Blue PC2 send packet from Blue PC1. Yes, let's communicate. But when send packet, YOLO PC1 and Blue PC1, they are connected in a router, in a same router. But if I send packet from YOLO PC1 to Blue PC1, send packet to YOLO PC1 to Blue PC1, they are not communicate. Destination and receiver. Clear? Jesus? Yes. Okay. So second one, you just finish the configuration. Now you need to check the or the verification, how to show out table. Then you can getting the routing instance name, then inet.0. If here IPv6 configured, then inet 6.0 will be there. Just place the command here, run show table, run show route, then help. Then table, then help here. inet.0, this is the master table, blow.inet.0, yolo.inet.0. You can separately see the routing table. YOLO routing instance table. You can set here blow routing instance table. WSWeb database. Oh, okay. I show you. Then go to show interface stars routing instance, then routing instance name. How to see the WSWeb database? When you see the WSWeb database, run show WSWeb, then place here run show WSWeb neighbor, then instance, then instance name, YOLO. In YOLO routing instance, OSPF not enable. We configure here static routing, but in blue, configure OSPF, and OSPF status is up. Okay, you can set here any command like database, then place here which database you want to see, then place the instance, then name of instance. Okay, this is the OSPF database of blue routing instance. Clear? Your normal command is okay up to now. Then set the instance and instance name. Simple. Instance, then instance name. Okay. Yes, it is clear. Okay. Show interface starts. If you want to see the interface information or interface status, show interface starts, then routing instance, then instance name. If you place here run show interface starts, this will give you the global routing table or global table, specific global table information. If you see specific information, routing instance blue, then place here only blue routing instance interface is showing here. If you place here yellow, yellow is showing here 0/0/1, 0/0/2. If you send ping or trace route, you have to use routing instance. Just I am sent one ping from BMX1 to BMX1 to PC2 or yellow PC2 or blue PC2. If I send ping run ping, normally we send ping run ping BPC2. BPC2 IP is this one. If I send it, this will not work because this is not in the global routing table. This is in blue routing instance. So you have to mention routing instance. Routing instance and routing instance name is blue. That will work. Yes, getting ping. Clear this is? Okay. Now, if you want to add IPv6 in this topology, just consider here IPv6 IP. Actually, this PC is not IPv6 capable. This is the problem. You can configure IPv6 here. If you configure IPv6, they will make the difference like run show route. If IPv6 configured, there will be another table will be there, inet 6.0. Blue.inet.0. Okay. Need to change the PC. Basically, this PC is not capable to forward IPv6 packet, I guess. Just check. IP DNS, IPv6 DNS, IPv6. Attempt to obtain IPv6 address. Maybe written as /26 or 26. IPv6 IP. It's okay. Attempt to privacy address. Mask data using Slack auto. No manual options. Mm, yeah, IPv6 bat command. Bat command. Mm, okay. We need to change PC to check the IPv6. Okay. Actually, is it okay for today, or I will go next topics? We show static routing instances, others similar I also show the voice web configuration. Some keyword is there. Um, I will discuss better in separate class, because I in book there is no IPv6 in routing instances, but I would like to add IPv6 in routing instances. Okay, that will be in a separate lab. This PC will be um, disconnected, and another device will be connected, which is IPv6 capable. So in next class, I will show you same lab. Just I change the PC. I connect here IPv6 capable device and test the both IPv4. Today I have checked IPv4, and in next class I will add IPv6 also. Okay, just as I have a separate class in 11 a.m. That's why I have to close now. Okay. Okay. Thank you. Thank you. Stop.